Hello, everyone, and welcome back to another bit of professional learning here with the Georgia Department of Education Community for Music Technology. I'm really excited that I decided to do this particular series. So, this is a continuation of the series that we recently did on microphones. I felt like I had to gloss over several topics, and because I glossed over several topics, that made me want to go back and hit those topics again. And then when I started hitting those topics again, that brought up more research and more topics and more stuff that I wanted to share. So lo and behold, here we are, continuing our discussion of microphones for three more sessions here. So we're going to continue our talk about microphone uses, and particularly giving you some in-studio help with placement, setup, how to use multiple microphones at the same time and avoid phasing issues, all that kind of stuff. So let's just dive back in, and let's remember that our key points here are that we need to choose the right microphone, we need to face it in the right direction, and we need to plug it into a preamp. Now, most of us are not going to have that many options about exactly what kind of preamp that we plug our mic into, whether you're going to have a nice tubed preamp or you're going to have a high quality Apollo interface or whatever. We're probably using whatever interface we were given, and there's not much choice for that. But we do have more choices generally for choosing the right microphone and making sure that we face it in the right direction. So we're going to keep going in that front. The golden rule here: use your ears. Wherever the sound is best for your ears is probably about the right placement for the microphone. So don't forget that concept. As we continue to roll through this, it's really important to make sure that we're always thinking like, where does it sound best? Where does it sound best? Where does it sound best? That's going to give you a really good idea. Now, there are certainly things we can do to enhance and change sounds, but keep that in mind, especially if you're using just one microphone. And as always, if you're using any type of directional mic, so that's any direction other than just an omnidirectional mic, then you have to deal with the proximity effect, meaning the closer that microphone gets to its actual subject, the more bass response you're going to get. So if your mic is a cardioid microphone and you're drawing closer to your mouth, the closer you get to your mouth, the more bass heavy that response is going to be. The further you go away, the more bass is going to be leveled out. So you can use that in its efficiency to make your sound be exactly the way you want it to. So just keep that in mind. Microphone levels. We hit this a little bit, but I want to go back and hit this again. And if you look at this picture right here, if you have a microphone that's coming in to your DAW, whatever DAW it is, and you're looking at the channel input, and this is what you see on your meter, or this is anywhere close to what you see on your meter, then we have a problem. And that problem is that your microphone is turned up too hot. You are getting too much signal in and not allowing enough headroom. So we're trying to maintain at least 10 decibels of headroom between the peak of our sound and the top of what our DAW will allow. Now, if you're recording in 32 bits of audio, you're actually going to be able to maintain a higher level of headroom than you would if you were doing 24 bits or 16-bit audio recording. So do think about how you set up your DAWs. I know a lot of us don't want to take the leap into the larger amounts of memory that it would take to record into 32-bit sound, but the potential to have more headroom is there. So do remember that possibility. So without getting too technical, the digital sweet spot of recording is generally somewhere around negative 18 dBs. So on that meter that you're seeing, that's roughly here on that meter, right in the middle of this 12 to 22, maybe slightly closer to the 12 side because it's a little exponential, but um, it's like here. So if your meter is blasting out and you're getting into yellows or oranges or reds on your meter, you need to have the kids back that gain level down so that you get in there. So you should be riding around -18 with your peaks no higher than -10. So make sure that you're 100% not peaking higher than -6. But -10 should be your goal. There are so many ways that you can make a sound louder as you go in, through compressions, through just gain uppers, through all sorts of stuff, and it will maintain a really solid signal. But if you have a ruined signal due to clipping from your microphone being too hot or too loud, you're never going to get that back. So bear that in mind and keep your microphone levels running at around -18 on the run and peaking no higher than -10 if you can. That will make a big improvement to the quality of your sounds that you are getting. Okay, so one thing we glossed over in the last series about microphones is this idea of phase. And we said, like, if you were setting up microphones on a drum set, or you're setting up microphones to record a guitar or whatever, and you have two microphones, that just needed to watch out for signals being out of phase. Well, if you don't understand what phase is the push and pull on the microphone diaphragm. So as the sound wave comes into the diaphragm, it's either pushing on it or it's pulling on it. And if you have a sound wave coming into microphones that are set like this to one another and faced at the same thing, then the result is the sound wave is hitting here at maybe a different push and pull point than it is from hitting this one. And that becomes a problem because sound waves can constructively or destructively interfere with one another. So as this picture here suggests, if your top microphone or your microphone on the left is picking up the top or compression side of a sound wave, while the microphone on the right is picking up a refraction moment or a low pressure moment in the system, then in the electronic signal and the DAW, those are actually going to cancel each other out and nil one another. If you were to get this exact thing to happen, which is virtually impossible in an actual acoustic environment, by the way, but even if it's close and this happens, you're going to wind up with no sound wave. If it was perfect like this, you would have no sound coming out of the system. So it's really important that we manage the phase on microphones and try to figure out how we avoid deconstructive interference of microphones, because you can lose a lot of good sound due to deconstructive interference if you're not careful. So I'm just going to go through here a few more things about phase and why that could be an issue. So if you look kind of on the left side of this video, then you see that there's two sound waves that are there, and they aren't perfectly out of phase with one another like they were in the last video, but there are moments where they're out of phase. So you can see the resulting sound wave of those top two being added together in the bottom. There are moments where that signal is diminished and then moments where that signal is amplified. So when it's amplified, we get constructive interference, and when it's diminished, we get destructive interference. So these are just the things that we are trying to avoid in our placement. So why do phase issues occur? Well, the direct distance from the sound source is a big one. So the sound wave will be in different phases of its waveform at different distances from the sound source. So if you happen to line up two microphones just right, you're going to be really doing a lot of destructive interference based on the distance they are from the singers. So it's important when you're setting up microphones that are close to each other that the diaphragms are like exactly the same distance from the sound source. Or that sound is made of many different frequencies. So even if two microphones are placed equidistant from a sound source, the chance of all frequencies lining up is practically nil. So you just have to be really careful and do a lot of listening here. So tips to avoid phase issues. Do not point microphones at one another. Consider using phase flip switches. So oftentimes this will be a button where you see a circle that has a straight line through it. That's a phase flip switch. So if you're having a lot of issues, you think with all of a sudden the audio sounds really weird when you've used two microphones, flip the phase on one of those microphones and see which way you're getting a better sound. You know, if you accidentally have soldered a cable and soldered it backwards so that like slug 1 goes to slug 3 on the XLR cable, you're actually flipping the phase in the signal itself, which can be a problem, and another good reason to have a phase flipping switch to be able to get the right result out of there. Place microphones equidistant from low frequency sound sources, especially. Follow the 10 decibel rule and follow the 3-to-1 rule. We're going to look at those a little bit more here as we move forward. So do not point the mics at one another. And this is one really good example that I can think of here. So if you were recording a snare drum and you put the microphone on top and straight on bottom to the microphone, to the diaphragms. So what you're doing when you strike the snare is you're hitting down into the top head. So the first sound that microphone picks up is going to be a refraction, a lowering of the air pressure. So we're getting that lowering point of the air pressure. Well, by nature, when that strike goes down to the bottom head, it's pushing on the bottom head, so it's making a compression. So when that drum head is struck, the top head is making a refraction, the bottom head is making a compression at the same time. So that's causing a phase differential. So you're creating that issue there for the microphones actually naturally being in different parts of the signal. In this case, you would want to use that phase flip button to be able to switch one. And this is what that button generally looks like. So if you see this button in your DAW or you see this button on your preamp, this means phase flip. So you can actually reverse the compressions and the refractions, or the positive polarities and the negative polarities, to be able to get that waveform to actually switch top to bottom, a mirror across the x-axis there. So be mindful that switch is fun to check and make sure it's working right from time to time. So the 10 dB rule. When multiple microphones are in close proximity capturing the same sound, it's best to have at least 10 decibels signal difference between the dedicated mics and the auxiliary mic in order to minimize phase issues. So if you've got multiple microphones and you can angle them such that the microphone that's pointing the opposite direction is receiving 10 decibels less signal than the microphone pointing toward your primary sound source, then you're probably okay. That 10 decibel range tends to be the point at which the waveform is small enough that it's not going to have a drastic effect on what you are hearing when it comes to destructive interference. So how could you test for that? Set up your two microphones, have your person on side A of the room sing. If you see their signal on that microphone come in 10 decibels higher than the other microphone, then you're following the 10 decibel rule. If it's not coming in at 10 decibels difference, then you need to do some adjusting to the directions of the microphones to potentially minimize phasing issues. The 3-to-1 rule. This is a really interesting one, and I think particularly useful if you're thinking about choirs and the such. So the 3-to-1 rule states that when two mics are capturing a similar sound source, or you have multiple sources in one space, the mics should be separated by a distance 3 times that of the shortest mic to source distance. So if you're setting up 2 microphones on a similar sound source, let's say even like an acoustic guitar that we talked about, setting 2 microphones, one up higher, one down lower, those microphones need to, between them, if there is 1 foot distance away from the closest mic to the tone hole, if that distance is 1 foot, then the 2 microphones need to be at least 3 feet apart. So you're getting that. If it's 18 inches, we need 4.5 feet between the 2 microphones. So really getting out a ruler and beginning to understand what these dimensions look like is useful. Having a tape measure in your studio is a very good idea to be able to make sure you're getting things that are going to minimize problems with the recording phase issues. So here are some tried and true research-based mic placement ideas for good recording scenarios. The first one is this XY pattern, and it's one that we've probably all heard of at some point in time or used. And the idea here is that you're going to place 2 diaphragms as absolutely close to one another as you possibly can at a perfect 90-degree angle, with the sound source being centered between the 2 microphones. So here the microphone on the left side is actually capturing the right side of the ensemble. The microphone on the right side is actually capturing the left side of the ensemble. So as long as that's at a perfect 90-degree angle, you're getting a nice, big, almost omnidirectional, when you really see the pattern drawn like this, setup, and you don't have to worry about phasing so much because the 2 diaphragms are so close to each other that the sound waves are going to virtually be in the exact same place. So you can either do one of 2 things, and this is the one I recommend. You're going to set the 2 diaphragms on top of each other. So you've got one microphone that actually is setting above the other microphone, because the diaphragm of this microphone is not the very tip source. It's actually back in a little bit. For this particular one, if I was to show it to you, you can see that it exists just a little bit behind that opening plate there. So those would be the sources that I'm trying to line up. So I'm going to be lining that up. I think we're having some power issues at our house. Lining that up over top, and so that they face that way. The other option is to put them side by side and have the very tip edges of the microphone touch. So something more like this. And that issue is still probably going to work, but I would tend to think that the over-under pattern is a little bit better. So that would be one way to look at it. The other is the ORFT pattern. And here, this is taking advantage more of that 10 decibel rule. So if I place the microphones away from each other at 110 degrees, then the decibel loss from the source on the left coming in to the right microphone is going to be over 10 decibels. And that's why this begins to become such a useful pattern. So here, the diaphragms on the microphones, so not the back ends of the microphones, but the front ends of the microphone, need to be 17 centimeters apart, and the microphones need to be angled 110 degrees from left to right. So this is the ORFT pattern. So this could be placed in front of a band ensemble or orchestra ensemble or whatever, and becomes a really nice way to capture a very wide, pretty set of sounds that you're going. Now there's another version of this where you would use 30 centimeters of placement and 90 degrees of angle. That's called NOS, by the way. Mid-side pattern. So if you want to use two microphones on a mid-side pattern, then you need your mid microphone to be cardioid, and it's going to face straight on at the ensemble. So the cardioid microphone straight down the middle of the ensemble. Then you are going to have a bi-directional microphone, meaning it picks up from the front and the back but has dead spots at the side. And you're going to turn that so the dead spot is at the center of the ensemble. So you can see that kind of over here in this diagram on this side. So the important thing to remember then is in the mix, you need to take your side or your bidirectional microphone, duplicate the signal, so make an exact copy, pan one hard left, pan one hard right, and flip the phase of one of them. Not both of them, but just one of them. So now when you collapse the stereo signal into mono, the side information is actually going to cancel out, and you just get this really nice, beautiful sound. So mid-side pattern is also really quite good for acoustic guitar recordings. Just really, really cool sound that you're going to get out of this mid-side. You'll be amazed at how big the actual sound is going to be, and very full. Decatree is the other option here, and this one is a really interesting. It's become super popular for musical ensembles and like high-end recordings, and you only need 3 microphones. So the secret to this is that in a Decatree you need 3 omnidirectional microphones. So they're arranged in a T pattern. The bar of the T is 6 feet apart, and the front mic is then 3 feet up from center. So if there's a center point, each mic is 3 feet away from the center point of the microphone. And again, the key to this is them being omnidirectional microphones, and you place that center front mic right over the conductor's head, and that's where you're shooting for in order to get that really nice sound. So hard pan the left one, hard pan the right one, leave the middle one in the center, and you get a really nice big sound. So this has been a discussion of different mic placements and how to set them up in order to avoid phase and potential issues that might occur. In the next couple lessons, we're going to see how to implement these ideas in specific recording scenarios that you might run into. Thank you so much for watching. Can't wait to see you for the next session. See you soon.